All right, welcome back, guys. We're going to go through the numbers 3 through the end of this. How many are there? 9? No, 10. No, 12. Okay, 12 of this assignment. So let's go ahead and get started with number 3. Softball player who's slowly sliding into the base. Label and use equality marks on the force vectors. I'm going to walk through this one very slowly, and then I'm going to actually just go through the other answers pretty quick. This one I'm going to draw live here, and then the other ones I'm going to pause the video and recording, and we'll get them drawn in. So the first thing that we want to do is we want to, since the drawing's already done for us, remember we have that, let's see if I can go to the reading and the notes, and we've got the steps. Let's zoom in here a little bit so we know what those steps are on this page. There's our steps. Step 1, sketch the system. 2, enclosing in a boundary. We're going to do that. 3, we're going to shrink it down to a point with a coordinate axis, 1 parallel to the direction of motion. And then 4, represent all relevant forces with a labeled vector, and then indicate which ones are equal. That's what we're going to do on this assignment. So let's get started with that. Step 1's already done for us. There's already a drawing. Step 2, we're going to circle and I circle it with, go through here, with yellow. I know yellow is kind of hard to see, but I don't want it to stand out too much. The girl is what we're drawing forces on. Softball player. So let's go ahead and do that, and we will draw a dot over here to represent that. There's the softball player, and we'll start to analyze and draw the forces. We got a coordinate axis we want to put up here first. Direction of motion, moving to the right. So we have a left-right axis, and we have a, left-right axis and a up-down axis. Okay. Drawing the forces, the first one we have is gravity. That's down. That always is going to exist. Force of gravity. That's on the softball player. I'm going to go SP for that one, softball player, by the earth, big E for that one. Excuse me. Next we have is the ground. The ground is supporting her, so that's going to be a normal force pointing up. Up is the normal force. And we have the force, normal force up on the softball player by the ground. And finally, as they're sliding, you have some friction, a force that we call friction. And the friction is always in the opposite direction of motion. So she's going to the right, moving to the right. So friction is going to be to the left. To the left. And it's only a small amount. All right, or it could be a big amount. This is on the softball player by the... It's really relative. It's obviously not as much as her weight, so don't, or her, the force of gravity on her, so don't make it that big. But, it is quite a bit because it's stopping her entirely. And this could be by the ground as well, or by the dirt. I'll say ground. All right, and those are our diagrams, and we have forces that are equal. She's slowing down as she slides, so this makes sense. We have the up equal to down. That's it. There's nothing to equal out the frictional force. There's nothing that she's like pushing into. She's not static. She's sliding into the base and slowing down. So she's slowing down. That's what it says up here. So therefore we have a force unbalanced in the direction against her motion, which means slowing down. All right, I'll go ahead and get the rest of these done, and then we'll be back with you in just a quick second. All right, we're back looking at number 4. This is a lamp on the ceiling. We've got the gravity. That's the force of the gravity, or force of gravity, excuse me. That's on the lamp by the earth, straight down. And we've got tension from the chain holding the lamp up, providing an upward force. Those two are equal since it's just suspended there. Nothing else is touching the lamp, so no other forces. Number 5, I circled the key phrase here, constant speed. The bucket's being raised by constant speed. That means no acceleration. That means no net force. All right, no acceleration, no net force. Gravity is pulling the bucket down. Force of tension in this rope right here, that's what we call that. In a rope, in a chain, anything that's pulling, being used to pull something else is going to have some tension in it. Even if it's like something that's rigid, like the handle of a like a wagon or something, there'd be tension in that rigid object as well. We usually reserve it for being used for non-rigid objects, and we usually lump the if it's like a wagon and a tight handle, we lump it together. But anyway, tension on the bucket of the rope, those two are equal because it's constant speed, up and down. Remember that balanced forces are not necessary to have an object continue to move or to keep moving. It's to get it started moving or stop it from moving. It's basically a change in acceleration. Speed up, slow down, or change direction needs a force. All right, number 6, this is the diagram for the skydiver who's still speeding up as they're going down. So they are speeding up, which means the gravity force down, speeding up down, so down gravity is bigger than the drag, or that's what we call the force of air resistance pushing on things that are moving. Even if you hold your hand outside of a passenger window or something while you're driving, you can feel the drag on the air. You can actually do a cool experiment, hold it out this way, and then turn it sideways, and you can feel the drag change. Much less this way, much more this way. Anyway, so they're not equal. The down one is bigger than the up one because it's accelerating. Here's the opposite situation. This is a parachute that's opened up, and they're descending at constant velocity. So this is when the force of gravity meets the force of the drag of the air, which is what a parachute does. A parachute will allow that to happen. The speed that you fall at with a parachute depends on your weight and the size of the parachute. A bigger parachute will have you fall slower, smaller parachute less slowly. And if you're heavier, you'll fall faster. If you're less heavy, you'll fall slower to a certain point. Draw a ball being thrown in the air. These ones are very uninteresting. There's one thing that you could put on there, but I left it off of this one. But there's a small amount of wind resistance or air resistance. Air resistance is a function of the shape of the object and the speed of the object. So a ball is very is very aerodynamic, so it doesn't really mess with the air. Doesn't mess with it too much, and the shape. So the shape, and then the fact that this isn't moving very fast means that there's little to no air resistance. If you wanted to put air resistance on here, you have a little arrow kind of following this parabolic curve here, tangent to it, off to the side here. That would be okay if you drew that on there. Otherwise, it's just gravity pulling it down. Same thing for when it's at the top of the trajectory. Nothing else came in contact with this ball, so there's no other forces that could, unless it's the air or the Earth gravity, which is always acting on these objects. Numbers 10, 11, and 12. Number 10 shows a cork floating on some water. Floating is what we call a buoyant force. And look, if you notice something, all of these are kind of what's counteracting gravity to allow it to stay where it's at. So why doesn't the cork sink? Technically the cork displaces enough water that's equal to its weight. So therefore, since the water pushing up is equal to its weight pushing down, then it's balanced and it floats. This is true with everything. This is the same reason that big, massive cruise ships that are the size of hotels and several restaurants can float on the ocean. They displace enough water. This is why a big chunk of them are underwater. All right, the airplane is a similar idea. We've got the fact that we know gravity's pulling it down, so something's got to push it up. It's unlike water. It's in the air. In air, we have to have something called lift. Lift is the force that is provided by a pressure differential between the top of a wing and bottom of the wing of a plane. You can feel this as well if you're driving your car. You stick your hand out the window and have it sideways like this. If you tilt it, you can feel if you tilt it up this way, you can feel the air start to try to push your hand up. If you tilt it the other way, you can feel it start to push your hand down. So just the shape of the wing allows it, as it's flying fast, to get a lift up. And if you notice, the flaps open up and do that same angle. If you want to go higher, you close the flaps or slow down, and it'll lift you up by the tilt of the wing and the speed of the forward speed of the plane. And those two are balancing out gravity. On the plane by the air. Notice I started dropping the gravity writing that out. You're going to eventually do that. Please, you can feel free to skip the gravity one if you want, but list them out on all the others. Last one's the magnetic force is what's holding this up. So we've got the force of gravity down. Now this one, the magnet is actually touching the object, but know that magnets don't have to touch. So if you somehow were to have it at the right distance, perfectly balanced, you could get it to kind of levitate. It would be pulled down by gravity and up by the magnet at the right amount, the perfectly right amount. The problem is this is a magnetic and gravity are both similar, so it'd have to be a pretty strong magnet, and it would have to be very particularly balanced in the right area. And also, that's not entirely true because of the fact that it's still pulling on the particles or atoms that are at the bottom of this nail and the ones that are at the top, if we're talking about magnets for real. But for now, we're just thinking of it as one single nail, and it's being pulled up by the magnet and down by gravity in an equal manner, so it's not moving anywhere. All right, that was the last one. Send me questions if you have questions. Otherwise, we're all done here. Hopefully that helped out. Thanks.